Now, following up on a video that I just did, I decided to show how to derive the length of a coax cable using the MFJ-269, which I own since many years now. This device can do actually many things. It's not very intuitive maybe, but if you know how to use it, you can do many things with this. So when let's start switching it off and on again. So you want to start connecting your cable. You want to measure. On the other end, the cable is open. And once you're here, you want to push both these two buttons, both together, until you get to the Advanced 2 menu. Then you release, and it will ask you the velocity factor of the cable. Now, if you don't know what cable you have, then probably you don't know the velocity factor either. If instead you have some information on the cable, you can enter here the velocity factor. Now, what I've done here, I don't have any marking on the cable actually. There's no mark. It's not marked. I have bought this cable used from surplus, and I remember it was about 10 meters, but then I have already used some of it. So obviously, if the cable is not too long, it's quicker to just use the tape to measure it. But if you have a long cable, if you have a long one, this is easier. So what I've done in this case, I've checked the diameter, because the cable was, when I bought it on the website, was sold as being an RG316. But the diameter of this cable is a bit bigger than the RG316, which is around 2.5 millimeters. This one is 3-ish. So I have checked the version of the RG316, the one with the double shielded is called RG316 the -DS, which stands for double shield. And apparently the dimensions they give are the same I have here, about 3 millimeters in diameter. So I'm assuming now that this is double. Actually, I have checked already that it's got 2 shieldings, so I'm pretty sure that's double shielded. Okay, so now from the data sheet, I saw that the velocity factor is 69.5. So we can enter the factor here. You can increase with the upper button, and you can decrease with the lower button. So let's put it like 70, okay, 0.7. Once you have the right number, you want to push both buttons together, and it will accept. And you go in distance to fault menu. So now what you have to do is to take the first measurement, and the measurement consists of looking for a frequency where this needle goes down to 0. So as you can see, I'm on the first range now. As you can see, I cannot put it down to 0. So I'm going to switch range over to the next one. And as you can see, going up here, we can find the minimum, which is around here. Once you find the minimum, you push the gate button and it will register this first measurement, and it will ask you for a second measurement. And you have to find the very next dip. So you go up in frequency. I have reached the upper limit of 10 megahertz. So I will switch like the next range, going back to 10 and continuing up on frequency until I hit the next dip, which is this one here. Now you push gate again and it will calculate the length. So the distance to fold, because the open is seen like a fold, is 23.8 feet, which, if you get a calculator, the only thing is it gives you the distance in feet because this is made in America. If you get a calculator. Okay, 23.8 feet is in meters. You want to multiply by 3048, which is the length in meters of a feet. And you got the result, 7.25. So that is the length in meters for this coax. And in fact, I have measured with the tape, and it corresponds. So yeah, that's all. That's the easy way if you have a long cable and you don't want to bother measuring with the tape. And if you've got one of these, you can do it. Otherwise, if you don't know the velocity factor and you want to find it, then you can measure the real distance, the real length of the cable with the tape, and then you compare the real length with the length that you derive with this, and you will get the velocity factor. That's the trick. Anyway, thanks for watching.